Okay, in this video we're going to do a little more with radical exponents, and I left up the exponent rules that we talked about in the last video. So if you haven't watched that one, you want to go back and watch that one. So we're looking at radical exponents again. So let's remember we've got x to the m over n is going to be the nth root of x to the m, or the nth root of x to the m. Either order is fine. All right, so we're going to look at some operations. So we're going to put together this with the stuff that's on the left. So for example, let's say we have 8 to the negative 1/3. All right, for the most part, the order of all of the things on the left does not matter. So for example, I've got 8 to the negative 1/3. I could do the radical exponent that's here, or I could do the negative part. It doesn't matter which one you do first. So negative exponent is the last rule down here. I remember that means reciprocal. So this is reciprocal. I could do that first, or I can do them both in one step. So reciprocal, and then the 1/3 means cube root. Okay, so you can do that all in one step if you want, or you could do cube root, and then you could do reciprocal. All right, so now I've got 1 over the cube root of 8, so 2 times 2 times 2 is 8, so I get 1/2. Okay, so remember, a negative exponent does not mean negative number, it means reciprocal. Let's say we've got, let's look at the difference here. Okay, negative 8 to the 1/3. See the difference here? So this one, the negative is in the exponent. This one, the negative is not in the exponent. So this one is saying cube root of negative 8. Okay, see the difference there? Negative in the exponent means reciprocal. Negative inside the root is just a negative inside the root. And we remember that we can take cube root of a negative number, so we'd have negative 2 times negative 2 times negative 2, and that comes out to negative 2. So that's the difference between a reciprocal and a negative number. All right, so let's look at a square root with that too. So 16 to the negative 1/2. Negative in the exponent means reciprocal, and that means square root. So I've got 1 over the square root of 16, reciprocal and square root, and that's going to give me 1/4. But if I try to do negative 16 to the 1/2, that means square root of negative 16, and that is not real. Okay, so that's putting together, some of what we've seen with the negatives with the negative exponent. All right, let's try some more. So now let's try some operations. So let's do x to the 2/3 times x to the 1/3. All right, so when we multiply two things with the same base, that's this first rule over here, we're going to add the exponents. So we'd have 2/3 plus 1/3. They already have a common denominator, so I can just add them together. That would be 3/3, which is the same as 1. Okay, so when you multiply matching bases, you add the exponents. And when we divide, let's say we have x to the 1/2 over x to the 2/3. Okay, and dividing is the second rule. Remember that we subtract the exponents. So you take the one on top minus the one on the bottom. So I'd have x to the 1/2 minus 2/3. We're going to have to get a common denominator for that. The common denominator is 6. So this would be 3 over 6 minus 4 over 6. And when I subtract, I'm going to get x to the negative 1/6. All right, so this is a lot like the ones that we were just looking at. Depending on the context, that decides how you want the answer to be. So sometimes we would leave this as the final answer. So here, let me show you a few different forms. It might say write the final answer with no negative exponents. So remember, negative exponent means reciprocal. We could write this as x to the 1 over 6, or it might say write the answer with no fractional exponents. And this 1 over 6 would be the 6th root. of x. So these last three, I would say, are all acceptable answers. I think that iMath AS is going to be looking for this one though. Okay, so all three of these would be like decent, but I think it's going to look for this last one. All right, let's try another one. Let's do multiplying and dividing. All right, I'm going to go ahead and erase the exponent rules. If you don't have those written down, go back in this video and have them written down so you have them next to you while you're doing these. All right, so when we multiply, let's look at an example. Let's say we have x squared times 3x cubed minus 2x. All right, so this doesn't have anything to do with radical exponents. We're just remembering that when we distribute, let's remember what we do. So we do x squared times 3x cubed, and we would add the exponents, right? So we'd have 3x to the fifth because we're doing x squared times x to the cubed, and we add the exponents, just like the first line over here. And then we distribute, and we would do minus 2x x squared. We get minus 2x cubed. Okay, so that's distributing, which you've been doing, and I assume that you're all comfortable with that. So now let's try it with radical exponents. So let's say that we have, actually I don't have the example on here. All right, let's do x to the 1/2 times 4x to the 3/2 minus 3x to the 1/2. Okay, so same idea, we want to distribute. And here we did it in our head. I'm going to go ahead and write this out. So when we multiply, we're going to do 4x to the 3/2 times x to the 1/2 minus 3x to the 1/2 times x to the 1/2. All right. And we remember from our rule before, we're going to add these exponents. So they already have a common denominator. And when I add them, I'm going to get x to the 4/2 and x to the 2/2, and both of these simplify. So that's going to give me 4x squared minus 3x. Okay, and that one was nice because it simplified down like this. It started off a mess, right? These are two separate problems. It started off a mess, but it simplified down really nicely. Okay, and the last thing that we're going to do with this is we're going to factor. Okay, so this was multiply. And now we're going to factor. All right, so let's say we have something like 4x to the negative 3/4 plus 3x to the 5/4. Actually, you know what? Before we factor, let's remember a basic example, okay? So I'm going to do a little factoring one over here. Let's say we have 2x to the 3rd minus 4x squared. All right, so usually when you factor, you want to take out the largest number that you can and any coefficient. So I can take out a 2 and I can take out an x squared, right? And when I do that, I divide the coefficients and I subtract the exponents, because when we're multiplying, we add the exponents. To do the opposite, we subtract. So when I take out 2x squared, I'm going to be left with x minus 4. Sorry, 2, 2, 2, 2, 2, 2, 2, x minus 2. Okay, so we divide out the coefficients and we subtract the exponents. And when I have x squared and I take out x squared, it's gone. All right, so over here, taking out the biggest exponent doesn't really apply to radical exponents. So, and there might be different ways that you want to do this, but for what we're going to do is we're going to try to get rid of the negative exponent, because a lot of times that makes it easier to simplify. So I can't take out any coefficients. I've got a 4 and a 3. I'm going to leave those alone. And I'm just going to take out the x to the negative 3/4 because I want to get that negative exponent out to the front and try to simplify. So like if we're going to change this to a fraction or something like that. All right, so when I do that, okay, when I take that out to the front, this was x to the negative 3/4. I took it out to the front. There's no x left, just like we saw here with the taking the x squared out to the front. No x left. So we don't have to worry about any operations there. We took it out to the front, it's gone. All right, here though, 3x to the 5/4. I took a negative 3/4 out to the front. So normally we would subtract exponents. So I'm going to do minus negative 3/4. That's a little crazy, right? Because we're moving a negative out to the front. So we're going to do minus negative 3/4. And remember that negative is the same as plus plus. So we get 4 plus 3x. Okay, so now we're going to add these together. We're going to get 8 over 4, which is the same as 2. Whoops. Let's try that again. Plus 3x squared. Okay, so usually when we're factoring, we're trying to factor the messy part out, like the radical, the negative, all that sort of stuff, and hopefully what we're left with is something that we can work with. So 4 plus 3x squared is much nicer. It doesn't always work that way, but that's what we're trying for. So when in your homework, when they say factor, try taking the negative out and then see what you have left. And it should work out. They gave you some pretty straightforward ones. Okay, so that's operations with radicals.